Okay, so we all know how to multiply numbers, right? 5 times 3 is 15, simple stuff. But have you ever stopped to think about what happens when you try to multiply directions? Yeah, I know, it sounds kind of crazy, maybe even impossible, but it turns out this is the hidden engine that powers everything from basic physics all the way to 3D graphics in your favorite video games.
So let's just frame this whole explainer around one kind of playful question. What happens when you multiply forward by up? I mean, seriously, what would that even be? Sideways? Maybe it's just a number. Is that even a real question you can ask in math? Well, it absolutely is, and the fascinating part is the answer totally depends on what kind of problem you're trying to solve. Let's dive in and see how.
And that brings us to our very first challenge, which I'm calling the alignment puzzle. Just think about it for a second. In the real world, things are messy, right? Forces are almost never perfectly lined up. So we need a way, a mathematical way, to figure out how much two different directions are working together, or maybe how much they're working against each other. Okay, picture this. You're pushing a really heavy box across the floor. You're probably not pushing it perfectly straight, are you? Nope. You're pushing kind of down and forward at an angle. But the box, it only moves forward, right? It slides along the floor. So the big question is, how much of all that effort you're putting in is actually moving the box forward? How do we calculate just the useful part of that push? Well, the solution is this really elegant tool from math called the dot product. And honestly, it was designed to do one single job and do it perfectly. You give it two vectors, and it spits out a single number that tells you exactly how aligned they are. It's the perfect, precise answer to our whole box pushing puzzle. So here's the absolute key takeaway. The dot product basically answers one simple question. How much do these two vectors point in the same direction? And the result you get back isn't another direction. It's just a plain old number, what mathematicians call a scalar. If you get a big positive number, it means they're super aligned. A big negative number means they're pointing in opposite directions. But a number that's close to zero, now that's where it gets really interesting. So what happens when two vectors are not aligned at all? You know, when they're totally perpendicular. The dot product gives you a big fat zero. And why? Well, the calculation actually uses the cosine of the angle between them. And if you remember your trigonometry, the cosine of 90 degrees is exactly zero. It's this beautiful, perfect mathematical proof that your up force has precisely zero useful effect on moving that box forward. First puzzle solved. But, measuring how aligned things are is only half the story. What if you want to do kind of the opposite? What if you need to take two different directions and create a third, totally new direction from them? Well, that brings us to puzzle number 2, the orientation puzzle. Let's think about 3D computer graphics for a second. Any flat surface you see, like a tabletop in a video game, is really just defined by two directions, right? Its length and its width. Now, to make lighting and physics work correctly, the computer needs to know which way is up from that surface. It needs to find the one direction that's perfectly perpendicular to both the length and the width at the exact same time. So how on earth do you calculate that? Believe it or not, you can actually figure this out just using your own hand. It's this awesome trick called the right-hand rule, and it's the physical intuition behind our next mathematical tool. Come on, try it with me. Take your right hand, point your index finger straight forward. Now curl your other fingers upward toward the ceiling. Which way is your thumb pointing? It's pointing out to the side, right? You literally just created a brand new direction that's perfectly perpendicular to the other two. And that is the magic of our second amazing tool, the cross product. See, unlike the dot product, which just gives you a number about the vectors, the cross product is different. It takes two vectors in, and it gives you a whole new third vector back. It's not just measuring something, it's creating something new. Okay, so now we have our two super powerful tools. We have one that measures alignment and another that actually creates new directions. So let's put them side by side and really see how they stack up against each other. So it really all boils down to this. You've got the dot product, it asks, are they aligned? And the answer it gives you is just a number, a scalar. This is perfect for stuff like calculating physical work or figuring out how light should create shadows in a 3D scene. Then you have the cross product. It asks a totally different question. What's the perpendicular direction? And its answer is a brand new vector. This is absolutely essential for things like calculating torque or, like we said, finding those surface normals in 3D graphics. So you see, they're for two completely different questions, and they give you two very, very different kinds of answers. All right, so we've gone through a lot.
After all that, what's the one single thing you should really take away from this? It's this right here. Just think of the dot product as being like an analyst. Its job is to measure the relationship between two vectors. The cross product, on the other hand, is like the builder. Its job is to create a whole new direction from the first two. If you can just remember that, analyst versus builder, then you've pretty much grasped the fundamental soul of what vector multiplication is all about. And that leaves us with one final thought. We started this whole journey with a kind of weird question, right? Multiplying forward by up. But in answering it, we found these two incredibly elegant tools that are literally used to build the virtual 3D worlds we play in every single day. So the next time you're playing a video game or watching a big animated movie, just take a second to remember the simple but incredibly powerful math that's humming away behind the scenes. It kind of makes you wonder, doesn't it? What other incredible math is just hiding out there in plain sight, just waiting for us to find it?